once more into the Reach, and today we endeavor to learn more about the Godot engine. Specifically this time we'll be going over GDScript. Now there is another version of Godot currently available that will allow you to create scripts using the C# language. However, we're going to be focusing on the built-in language for the default version that was originally added they originally created for obviously the first version of Godot. And it'll be GDScript, which is based, for those of you who do not realize, GDScript is based on Python. And for this tutorial, there will not be a file system, as you notice, or there will not be included the files, because this time we're just going to jump straight into it. And the code that I create will be copied and pasted below, and you can just sort of copy the node structure here as you follow along. Now, as I may or may not have alluded to before, the Godot engine the GDScript language is based on Python. Now, the scripting language itself, it has many similar methods to Python, of course, but they obviously, in order for me to make a comprehensive guide on all of the methods included within the Godot API would be, frankly, a little bit ridiculous, and it could sort of be like a wiki page where there's like a video example of every single method. It would be ridiculous. It would be thousands, maybe like around 1,000-ish videos or something. So I will refer you to the API for that. What this video is meant to be, however, is an introduction to what GDScript is, some of the methods, more common methods that you'll be using, and to just give you the ability, hopefully, to be able to learn the rest of the API is sort of the goal here. Now, I went ahead and made our default scene. I just added a regular node to it and named it test like I usually do. And now we're going to work on a node 2D here. So, of course, the first thing that you want to do in order to use GDScript is you need to add a script to a node. As I've done here, I made this new scene. I'm going to save it here. I'm just going to call it Godot Buddy, I guess is the name I'm going to be using. I'm going to rename this as well to Godot Buddy. Now we're going to attach a script to it, and we're just going to have it path to the regular file, so it'll just pop up in our default folder right over here. There it is. And when you first start up a script, it'll actually give you a little bit of helpful information in order to sort of get you started without a tutorial even. Your class variables go at the top. For those of you who programmed in Java or most other languages, yes, you would usually put the instance variables at the top of the class header. Excuse me. The ready function is called whenever you add the node to the scene. That's very important to remember. And the process function is called every frame. Now I'm going to sort of back up here so that I can demonstrate a couple of things about the language. Firstly, because it is based on Python, there are no curly brackets. There's none of this. If I go ahead and just write out a method here, func method, you don't do this. This is not a thing. Although, of course, you can use it for certain applications. However, that's not really how it works. Specifically, whenever you create a function like this, you are supposed to use a semicolon like this. You hit enter and you'll notice that it is automatically tapped over. This is because that indented block there that's expecting for the error, by the way, just use pass if you want an empty method like that. So this give you that error. But the reason why it's indented like that is because, just like in Python, as long as that block is indented, it is considered to be grouped in. So in the case of this method, anything that I write that is indented one space over, like this pass, or let's just say var x is equal to 0, will be part of the method. Now, I went ahead and demonstrated the var functionality as well, a little bit ahead of what I wanted to do here, but var is essentially how you would declare any variable. It's more or less a generic type, so you can have a var be a integer, be a double, and yes, there is a distinction between doubles and integers, so when you're doing any type of calculation, make sure you're using a double if you mean for the value to be a double. So you put 0.0 there to make sure that it doesn't just clip off your decimal values, or it can be a string or really anything else, including an array of values like this and that. A little bit of cheekiness. But in any case, as the comment for the ready function did mention, the ready function is called whenever you instantiate an object. As you may have seen in the overview tutorial, I sort of instantiated the caret in the rabbit object, and you would do that in code. So whenever, or even when you add it to this, and whenever you add it to a scene, that's creating another instance of your object. So the ready function is sort of wherever you want to put everything. For example, let's say we just want to use the print function. This is of course your debugging tool for diagnosing scripts while it's during runtime. You just say print hi. So whenever it's instantiated, we'll get a little hi message there. The instance variables that you want to put at the top of your GDScripts, there are actually several ways and several tags, for lack of a better word, I can't immediately think of it right now, that you can use. Of course, you may use var and then name a variable and then value, just like that. That's an easy way to do it. But of course, this means that the variable doesn't really have a specified call time and doesn't really have a specified designation to when that variable needs to be defined. So before the var tag, you need to type in onready. This means that the var name equals 0 is defined when the ready function is also called. It's just nice if you want to have instance variables all grouped up at the top. So, and you would have seen me do this in some of the other tutorials, assuming that this GDScript tutorial is not the first one that you're watching. So onready var HP is equal to 0, of course, is called along with our ready function. And of course, you also don't even have to actually define values here. You can just leave it blank and leave a name and then define it elsewhere in the code. So specifically, I'm just going to go ahead and demonstrate making another method here. I'm just going to say define input. And that's just going to be its own method. I'm going to go ahead and repurpose this, I suppose. Make things a little bit easier for us here. I'm going to drop the pass line there. So we're going to define our input here. We're going to be using, for those of you who don't realize that Godot actually, if you remember input maps from the overview tutorial, Godot includes some default input maps. So what we're going to do here is we're going to just go ahead and take UI left, right, up, and down. And we're just going to steal those. Alright, so that's what that method does right there. We've assigned input to an array. Okay, so now the next thing that you want to do, and you'll sort of, you'll hopefully recall me going ahead and deleting the process method, and that's because I wanted to show how exactly that works, because the process method is not called by default. In fact, in order to make sure that the process method is called, you must use set process and then give this value a true. As long as this is true, your process method will be called every frame. The delta is necessary, by the way, and what the delta means is that it is it's called every frame, as mentioned, and that means that the delta is actually the length of time between every frame. So you can actually multiply values, for instance, speed by delta in order to get a movement. So for instance, if I were to define speed like so, it's equal to 100, and multiply it by delta whenever we update our sprite, it would actually mean that our look on me, wait for it, our object here will move 100 pixels every second, because there are 90 frames in a second. If we divide that time by the delta, then of course we'll get that value. So now I'm going to do something that I actually did in the other tutorial that I did, where I'm going to be using vectors to sort of shortcut our move method. And since I'm typing this out, I can sort of explain it a little bit. So vector 2s are most likely going to be your bread and butter in terms of what you're going to want to use in terms of movement, especially much so if you're doing it in 3 dimensions, of course. In 2 dimensions, you can get away with it a little bit more by using position.x and position.y. But in this case, what we're going to do is we're going to define a group of vectors, and actually I have to follow the order here that I'm using. So I need to use up here. So that'll be negative speed, of course, because the up is, of course, negative. You can also just use that negative right in front of the variable if you didn't know that. Some languages do support that. Most of them do, actually, now that I think about it. Instead of just doing 1 times -1, you can just put the negative right in front of the variable name. Save you a little bit of time, looks cleaner. Same thing with down here. And then the similar thing for the left and the right. Excuse me. A little bit of a trip up there. Okay, so now to define the comment, as you may have noticed before, is you just use the hashtag. And by the way, just to help you out, just give you the error real fast, use the pass. You can also highlight sections and press Control, hold down Control and press K in order to comment out whole sections. And of course, just highlight again and do the exact same thing to uncomment. You can also highlight several lines and press Tab to tab all of them over. And if you press Shift Tab, then you'll unindent all of those lines. If you're using the Steam version for whatever reason, you might want to rebind Shift Tab to something else. I'm going to be popping up the Steam overlay a lot. So now with that said, let's go ahead and use the input class. I'm sorry, I'm going to keep that there so I don't have that annoying error every time. We're going to be doing a for loop, and for loops are defined as follows. You are going to use when you declare a variable x in range, and you're going to say value 4. So this means this essentially declares for you the variable x, and then it will iterate 4 times starting at 0, 1, 2, 3, and then ends at 4. So now we can say if you remember input, we're going to call the input class here input dot is action pressed, and we're going to use one of the input maps, but instead of using one of these named inputs, we're actually just going to use our array value. So what we're going to say here is we're going to say input x, if it is pressed, then update the position of our object plus equal to move in x. So what exactly does this mean? And this is mostly verbatim, if I'm remembering it correctly, from the Rabbit tutorial, or the the Godot overview tutorial. Control S there. I just press Control S there to save. What this is doing is, let's say it starts. So we're gonna trace this here a little bit. It starts at 0. It starts at 0, meaning it's checking input up. If the UI is up is being pressed, which is just the up key. So if the up key is being pressed, is what this is saying. Then we're going to update the position by using the first vector in, by using the 0th vector in the array move. And that 0 vector is, of course, 0 minus speed. So what this does is it takes its position. Again, this is the shorthand, by the way, of this same deal. Except it doesn't purposely misspell position for you like that. But that is the shorthand of that, and what that means is essentially whatever key is being pressed corresponds to a specific vector that's being added. So if I press all 4 of them at once, you'll see that it doesn't move here. So I'm just going to go ahead and go back to our 2D scene and add our Godot buddy in here. Although it would probably help if I added a sprite so that we can see it, huh? You might ask, what sprite am I going to add? Because, like I said, I'm not including anything. Well, there's this wonderful sprite here called the Godot logo, and we're going to be using, it's actually called icon.png. We're going to be using that. If you've never run the project for the first time, by the way, it's going to ask you to select a main scene. That just means the scene that is run. Oops. Member name already exists. Oops, my bad. Okay, we're going to leave it at that. that was already a position, or that was already an instance variable defined. My bad. Drop that, use the arrow keys. Oops, it is. It's a little bit fast. Hello. Oh, you know what I forgot to do? You're going to want to multiply this by delta. Because we're doing 100, I'm doing 100 pixels per second. That's what I forgot to do. So there we go. 100 pixels per second. Blazing fast. As you can see, if I hold down all the keys, I don't get to move. If I hold down left and right, I don't get to move. If I hold it up and down, I don't get to move. That's because the vectors are canceling out. If you'd like one thing to override the other one, then you're going to have to program that a little bit differently. It's a little bit more complicated. I think this works for 4-dimensional movement, in my opinion. So with that initial spurt of information out of the way, let's go over a couple of more things before I wrap this video up. Firstly, I'm going to introduce the export keyword. That's what I was thinking of before. So the export keyword here essentially makes it so that whatever variable you define after export becomes something that you can edit in the inspector. This is helpful for when you want to define a variable and you're in the scene editor and you want to, let's say, modify a character's health, or in this case we're going to modify the message that our Godot buddy prints whenever it is instantiated. In this case we're going to have the default message be hi, and we're going to whoops, I've got something up there, and we're going to have it print the message. You need to say export var. You need to, oops, VSR, that's what I'm looking for. You want to say export var, and that's just because you need to specify what kind of variable it is. And keep in mind that you can't change this from a string to a double. You need to declare it as such. So if this was set as, let's just say like 9.0, like that, then it would be declared as a double. If you put a string there, it wouldn't work. Now if we save this scene, go over to our test scene once more, to the editor, look at our Godot buddy, check out its inspector, you'll notice that the message is now here. So if I go ahead and add another Godot buddy to the scene, I can change his message to, let's say, goodbye. See you, buddy. Hit the play. And as I said, we have hi and goodbye printed out there. So this is just an easier way for you to, if you're maybe introducing multiple types of enemies, then you could maybe have this value be like a 1, 2, or 3. So it would change the enemy type, the enemy AI, or it was something as simple as health, this health value, for instance. That would be a use case for that, and it's very useful. I actually found out about things too. A good friend of mine named Chaz, and do you know which Chaz you are? I have in my notes here that I also just want to mention this really fast. Of course, certainly if you've programmed at all before, you're familiar with else and if statements. However, the thing that goes past it, the else if, you just say elif. And then you want to give that like one of these. Yeah, and of course you would define your Boolean statement in the parentheses after the if, but this does not work. This does not work. It has to be elif. And I think this just might be by convention, just so that you don't get if and then else if confused with this. So it just has its own keyword in this case. So with that out of the way, the last thing that I sort of wanted to touch on was signals. And the way that I'm going to demonstrate signals here is first I'm going to unfortunately have to offer a second little buddy there. Sorry about that. As we're going to be using area 2Ds. Now I'm going to commit a bit of a cardinal sin by not creating a platform scene. We're just going to do this for convenience sake, since I'm not really going to be iterating on this to a full game, obviously. This is more just an example. Make an area 2D, give it a collision shape, and I would just like to reiterate that all physics bodies need to have a collision box. That's why you have this little area. Well, that's why you had the area. If I'm just going to do this real fast. That's why you have the area here. It's telling you, hey, I need a collision box, or a collision shape, excuse me. So we're going to go ahead and give it a rectangle. I might have tried to do the recording before, which is why I know that 30/30 is sort of what I want here. Now we're going to move this area 2D. We move the collision box on its own. I hit save by accident. I'm going to hit undo. Doesn't really matter. I'm grabbing it again. Okay, I'm just going to do this manually. I'm just going to transform its position. I believe the default room is 800 by 600, so 400. And then the 600 there should work. By 800, I mean 400. What is it? Oh, it's 1024, so it's actually 512 is the middle. Like that. And then we're just going to stretch this out by like 10. A little bit more than that. 20. There we go. Just so it encompasses it. So obviously we won't be able to see this just because it's an area 2D and it doesn't have a sprite attached to it, but that will work for our purposes. We don't need to really see what we're landing on in this case. We're just here to look at the script and think it's pretty. So obviously we need to give our own little guy his own area 2D so that we can use these signals. Now it is important to note as well that depending on the object, whoops daisy, depending on the two physics bodies that are colliding, one may receive a signal when the other will not. So in the area 2D's case, they both receive a signal that, hey, an area has entered my area, essentially. Now what are signals? I've kind of gone on a little bit about them and I haven't really explained what they are. Essentially, a signal is where the scene or the node emits there's a technical term for it, surely, but I'm just going to call it a broadcast essentially to another node to say, hey, this happened, and here is some information for you. In this case, we're going to be using area entered, and the way to get to the signals, of course, is you just click on the node right here, and then the signals tab, and then we say area entered, and there are several signals, as you can see, from that have been inherited, but we're going to be focusing on area entered. And then once you double click on it, as I just did, you want to tell Godot where you want the signal to be sent to. In our case, we're going to be sending it to Godot buddy. And as you can see, the signal is once the signal is being sent to Godot buddy, this specific method is called. It's actually auto-created for us here. I'm going to give those excess spaces. And now we're going to say how we want to handle this. Now, in some other engines, you may say if, oh, I don't know, if the area that I'm colliding with is an instance of a platform, do something. In this case, we can actually use something called groups. So I'm going to go back to, I'm in the test scene, right? I'm in the test scene. I'm going to change the area to the, next to signals is something called groups. Now, as opposed to doing that instance of I was mentioning, we can actually just give it a group name. And I'm going to, in this case, a platform. It's a noun. I'm going to call it platform. It's in the group of platform. You may use any string, and it's similar to the input maps, except in group form. So now I can use the function is in group. So specifically, I'm going to say if area dot is underscore in underscore group platform, then grounded is equal to true. And I'm going to go ahead and define, oh, I already did, I left it in. So yeah, that more or less confirms that yes, there was a botched recording attempt, unfortunately. And I am missing a end parenthesis there. But yes, so now we're going to go ahead and sort of make our own artificial gravity here, similarly to how I did in the Godot overview tutorial. Already, oh, actually we're going to use constant. This would be a constant value that will not change because gravity is a force of nature. Indeed. Use 100, actually. I learned my lesson. We're going to use something a little bit faster. We're going to use, 200 is fine. I'm going to be using 200 here. At the end, we're going to say if not grounded, as in our object has not hit the ground, then we're going to update our position by moving it downward, by adding gravity. Because again, addition is down. I'm going to say position.y here because we're adding to the y. We would have actually gotten an error there for trying to add an integer and a vector too. That wouldn't have worked. Yes, and the other thing here is just real fast. I'm just going to drop the moving up and down, even though it actually was a little bit of strange interaction there. But I'll let you sort of figure that out on your own. And this time I'm going to remember to change this to 2 because we've just reduced the size of the arrays. Okay. So in any case, after that signal is sent, we once you've overlapped areas, grounded will be true and we won't be moving downward anymore. I'm just going to cross my fingers and hopefully that, oops, okay. I didn't multiply this by delta. So what most likely happened here is it actually moved 200 pixels a second and it actually just hop and skipped right over the area anyway. So hopefully with that fix we'll get to see him land on the area. There he goes, and he can't pass except when I do this. Except that actually doesn't matter because if we wanted him to fall off, and here I can show that off actually. If we go ahead and hit play, he actually won't fall off as long as I hit the area first and then just walk off. As you can see, he's floating necessarily, and that's because that in that case, if you did want that to work, we'd use area exited. Now we'd more or less use this same snippet of code. Oops. Same snippet of code, but we'd set this to false. So once it has left the area, then it's no longer grounded. And that's how you would sort of set it up so that you could also just jump as well. You would give it a positive y value, add the positive y value, and then therefore we would have exited the area that it landed on and you would be able to jump again. Much more simplified way of doing it, I think, but it works. So now the other thing, so that's signals in a nutshell essentially. The other thing that you can also do with signals, of course, is you can send them yourself. And as you can imagine, there's a keyword for that, and that keyword is signal. And I'm just going to go ahead and make it landed. And to emit a signal, you use the command emit signal. A little boring, I know, but yeah. So then we're going to use landed here, and I would like to point out here that even though we just named it landed, we did have, without it's not a string, we do have to call out a string when we're doing it here. And similarly to when we use the export method, if you go over here to the test scene, I'm going to go and jump ahead into 2D. You'll notice when we hover over Godot body, we now have that signal that we can use. And this needs to have a script because you can't connect a signal to something that doesn't have a script. Again, this might have been a botched recording attempt. So we're going to connect that landed script, that landed signal over to the test script. And I'm just going to say touchdown. I don't know. it doesn't really matter. This is just for illustration, for illustrative purposes, demonstrative purposes, illustration. Yeah. Touchdown. There we go. And we're gone. And that is more or less all I wanted to show you. This is hopefully not comprehensive. That's not what I was going for. This is again just a general introduction to the GDScripting language, and hopefully this will give you the tools that you need to read the rest of the API and understand what you would need to understand. Again, there are also a lot of complicated topics in there, including vector math. So if you haven't taken, I don't know, I think calculus 3 is if you learn vector math. There's some stuff in there, but that's if you aren't doing anything that involves, that you would think it involves complicated vectors, anything more complicated than this, for instance, dot product, then you don't need to worry about that. But in any case, hopefully you found this video helpful, and I hope you all have a great rest of your day. Peace.